Hey guys, so in the previous recording, we have already considered a situation where we have two estimators. Both of these estimators are unbiased. So in order to choose between them, the criteria that we used was to compare their variances because the most efficient estimator is going to be the one with the smallest population variance. So we preferred estimator B over estimator A because it has lesser variance. So it's going to be the most accurate. And what we mean by accuracy is that it's going to be the most efficient, right? So when we have two estimators, both of which are unbiased, we prefer the one with lesser variance. So that was pretty straightforward. Now in this video, we're going to consider a different situation. Okay, so let's say that we are trying to estimate a certain population characteristic, theta. And here we can see that we have the situation where we have two estimators. Once again, let's call them A and B. And here we can see that one of these, that is estimator A, is unbiased. So A is unbiased, while the other estimator B is biased, but it has a smaller variance. Biased, but it has a smaller variance. So in this situation, how are we going to choose between these two estimators? Okay, so one of the criterion that is often used in order to choose between an estimator that is biased and an estimator that is unbiased but has smaller variance, we use the MSE, that is the mean square error. So the mean square error of the estimator is defined as the expected value of the square of the deviation of the estimator, that is z, minus theta, the whole thing squared, about the true value of the population characteristic. So basically, the mean squared error is a criterion that can be used in a situation such as the one that I just described. Okay, so an alternate way to express the same thing is as follows. So we can also show that the mean square error is equal to the variance of the estimator plus the bias squared. Okay, so the variance of the estimator is simply z is our estimator, so sigma squared z, plus the bias is simply mu z minus theta, and we're going to square this whole thing. So we can show that the mean square error can also be expressed as follows. So basically what we're saying is that our definition of the mean square error, which we defined as MSE, is equal to the expected value of the square of the deviation of the estimator about the true value of the population characteristic. So z minus theta, the whole thing squared. So we are saying here that this expression is equivalent to sigma squared z, that is the variance of the estimator, plus the bias squared. And in the next video, we're going to prove that these two expressions are equivalent.